Hello guys, hi, good evening YouTubers, hi. So hope everyone is doing great. Hi guys, how are you all? So welcome to class today. So we have yes, we'll be starting with electric potential again, and we'll be completing today the electrostatic potential. The electric potential class. Concepts of electric potential today. So waiting for the YouTube. Waiting for our live class students. Once they arrive, and we'll start the class exactly by 5 p.m. Yes. So waiting for their arrival. Hi Prajwal, namaskara, ಹೇಗಿದ್ದೀರಾ? So hope you guys are doing good. So ಏನಾಯ್ತು Prajwal, anything today so that if is there anything special today? There are very no students in any of the class. Is there anything special today? Okay guys, I'm quickly launching the technical poll. Okay, so there is Eid Milad today. Okay, so is it a holiday to you guys? Is it a holiday from Navodaya? Achha. Okay, I didn't know this. So we were not given a holiday, and we were not informed that okay, such things will happen. Cool. So ಮತ್ತೆ ಬೇರೆ ಇನ್ನೇನು ವಿಶೇಷ? Anything special other than that? Eid Miladun Nabi. I don't know. Maybe it's that. Okay, so Prajwal from Mysore. Okay, yes, na Mysore or Prajwal idera Prajwal EM, Prajwal S, and Prajwal one more Prajwal EM. Okay, guys. So hope. Oh, nice. 3 Prajwals. Hi, hi, all 3 Prajwals. Okay, Namrata. Hi. So Namrata, I think your email IDs which you are using in Zoom. Good evening, Prajwal. Yes. So the email IDs which you guys are using in Zoom is not registered. I think you have to register that or use the registered email ID which is been sent by you guys in your response sheet, right? So you have to use that. Otherwise, guys, your attendances are, all of you, your attendance is not getting recorded only because your email ID which you have provided to us is wrong or is different than what you are using in your Zoom account. So try to use that. Hi Mega, good evening. Okay, okay, I'm Namrata. Super. So guys, I hope you guys try to solve this question which is being displayed. Everyone, did you try? YouTubers, hi, good evening. So is there, if there is anyone celebrating Eid ul, I don't know, Eid Milad un Nabi, I think it's that. So yeah, please correct me if I'm wrong. Yeah, happy Eid Milad un Nabi. Okay. So yes, Namrata, but which you provided to us, guys, everyone in Zoom, the email ID which you have provided should be the same which you had, which you are using now. Like the Zoom registered email ID, we had sent you a Google Sheet, right? So a month ago, we had sent you a Google Sheet where we had collected your Gmail ID. So we are referring that for your attendance counting. One, if you have, if you are using a different thing, please update that email ID to us, or please use the email ID which you have provided to us. So guys, every day we are going to provide the attendance report to the student, to the principals of respective schools, to all Karnataka region students. Yes. Then one more thing is, maybe in upcoming few days, your account would be locked. Like whatever the registered ID you had provided, only those people could attend the class. Others may not be able to get the access. Okay. So not only to physics, every class of Zoom, every class of Zoom. That's the criteria which our central team has provided us the instructions to inform you guys. Okay, guys. So hope everyone have tried to solve this. The answer for this question was, yeah, the answer to this question was 20 micronewton. Okay, so yes, if you are worrying, if you are thinking about the setup, everything is different, guys. So I had to replace my laptop for some time. So what happened? Entire laptop got crashed the other day, and there is some issue. So it takes some time for me to adjust. So answer was 20 newtons per coulomb. The electric field for this was 20 newton per coulomb, guys. So hope everyone had tried to solve this and everyone got this. Meanwhile, I hope everyone have taken your polls, technical check. Yes, guys. So we can start the class now. Yeah, it's 5 o'clock plus 4 minutes. So yeah, I'm going to end this poll. So guys, yeah, hope everyone is able to hear my voice. I guess everyone got this problem yesterday. Did everyone solve this? The answer was 20 newtons per coulomb. The answer was plus 20 newtons per coulomb. Yes, I want everyone to respond. Please respond. If you guys have solved this, click on yes. Yes, you had understood this. Okay, let's have a quick recheck on what we had studied yesterday's class. We studied about. We'll have a quick revision. Okay, yeah, we'll have a quick revision. We'll have a quick revision. So what did we study in yesterday's class? Wow. Oh my God. So every time I need to check the pen. Yes, guys. We did not start with dipole, Amrata. We started with electric potential. So again, we are still in electric potential. Once this is done, in next class, after today's class, we'll complete electrostatic potential energy, electric potential, and equipotential surfaces also. In yesterday's class, we learned specially about electric potential. So V is equal to W external by Q. This is what we learned. That is nothing but change in potential energy, UB minus UA by Q. Yes, we studied about, correct, Namrata. We studied about relationship between, yes, what was the relationship between electric field and electric potential? Are they same, guys? Okay, this is not a scalar quantity. This is a, sorry, this is not a vector quantity. This is a scalar quantity. Anyway, I erased everything. Huh? Okay, so we started with 1. V is equal to W external by Q. That is nothing but UB minus UA by Q. This is nothing but the change in potential energy. Right. Next, we started with a relationship between electric field and potential. So, yes, this was not a vector. Sorry again. Electric potential is, okay, relationship between electric field and potential. So in this case, what we studied E is equals to minus dV by dr, guys. Yes, we studied E is equals to minus dV by dr. This was the first form. The other form, same thing can be written as E is equals to, or E dot dr is equals to minus dV. If we wanted to find the whole voltage, what is the potential? If we wanted to find the potential, what we had to do? What we had to do? We had to integrate this, integrate the above equation. So what we get after integration? We got integral of dV is equals to minus E dot dr, integral of minus E dot dr. So this turned out to be V is equals to minus E dot r. So this was the relation which we found. One more, guys, what was the other relation? What was the last relation we found? Using this, E dot r is equals to minus dV, or minus dV is equals to E r cos theta, E dr cos theta, sorry, E dr cos theta, or E cos theta is equals to minus dV by dr. Okay. So guys, we studied so much in our last class. Correct? Reply, guys. If you remember, yes. Let me know if you have, if you remember and you, yes, correct. Thank you. Thanks for the response, guys. So I hope everyone have revised this. In today's class, we'll be using this relationship to find the relation, okay, to find an electric field. So how can we find electric field using this relation? Okay, so to calculate electric field using the relation which we studied right now. So how can we do that, guys? How can we do that? How can we do that? So to understand that, yes, ER cos theta, correct, Hariprasad. Yes, to do that, so in today's class, we'll learn that. So to do that, what we have to do first? What we have to do first? Yes. So first we will consider three potentials. Say we'll consider 3 points A, B, and C. Okay, we'll consider 3 points A, B, and C. Let VA be the potential at A, let VB be the potential at B, and let VC be the potential at C. Now, okay, let A, B, and C be the potentials. Okay. Now, if these are the potentials or these are the points, and let VA, VB, and VC are the potentials separated by a distance r, then we know that E cos theta is equals to minus dV by dr, right? Right, we know this, right? We know this. E cos theta is equals to minus dV by dr. Now, if we know this, if we know the potentials, can we find out the electric field, guys? So, guys, yesterday while discussing, we also discussed how my electric field varies. If my theta equals to 0, what happens, guys? If my theta equals to 0, what happens? If my theta equals to 0, what happens? So we studied an example for also for this, how to remember and stuff. So in which direction will my electric field be? Guys, tell me. In which direction is my electric field? In which direction is my electric field? ಹೇಳ್ರಪ್ಪ ಮರ್ತೋಯ್ತಾ ಏನ್ ಕತೆ? Electric field ಯಾವ direction ಅಲ್ಲಿ ಇರುತ್ತೆ? In which direction is my electric field? So guys, okay, I'll give you an example, hint. So we had a tank, drum, whatever, the syntax which we had. So we had a pipe going to our homes, and there's a tap. We have a water bucket. So my water, if I consider my water as electric field, if I consider water as electric field, and the position of tank as, yes, yes, the position of tank with height h has having some potential, has bucket has some potential. So if I consider this as high potential, this is low potential, what can I say? Yes, super, guys, awesome, Prakash Konda, super, Namrata. Okay, ಇಬ್ರನ್ನ ಆನ್ಸರ್ ಮಾಡೋದು, ಬೇರೆ ಯಾರು ಮಾಡಲ್ವಾ? Others ಮಾಡಲ್ವಾ? Okay, Prajwal, thank you. ಸೊ ಏನಾಗಿದೆ, ಬೇರೆ ಅವರು ಆನ್ಸರ್ ಮಾಡಬಾರ್ದು ಅಂತ ಡಿಸೈಡ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ? ಹಿಂಗ್ ಕತೆ ಹಂಗೇನಿಲ್ಲ ಅಲ್ವಾ? Okay, sorry guys. Okay, it was yeah, please try to answer. Okay, so if this is my electrical system, say my water flows from higher potential energy system to higher potential to lower potential. Similarly, Similarly, even my electric field also, similarly, my electric field also moves in the direction from where to where? From where to where? From higher potential VH to lower potential. If I call VH as higher potential and VL as lower potential, my electric field moves from higher potential region to lower potential region, right? So if we have 3 points, VA as potential at A, VB as potential at B, and VC as potential at C. Can we identify the electric field at this point? If I know VA, VB, and VC, can I find E? Yes or no? Guys, tell me. Respond, guys, please respond. Respond. Can I find my electric field E? Excuse me. So if I know potentials, can I find the electric field E using this relation? Yes, no, ಏನಾದ್ರು ಹೇಳಿ. Yes, yes, correct, Ganesh. So yes, I can find my electric field if I know the electric potentials. How can I do that? How can I do that? So to calculate electric field in any given direction, so we have to follow these. To calculate electric field in any given direction, I have to follow these. So what is that step? The first step is I have to find EA. Say if EAC is the electric field along direction AC. If EAC is the electric field along direction AC, EAC is the electric field along direction AC, then EAC can be written as EAC equals to what? So electric field is equals to, electric field moves in the direction of lower potential to higher potential to lower potential, and the net potential can be found by using minus of change in potential. Guys, what is change in potential? What is my change in potential? Final minus initial or initial minus final? Yes. What is my change in potential, guys? Is it final minus initial or initial minus final? Yes. Potential at final point minus potential at initial point. Correct, Namrata. So, which is my final point here, guys? Which is my final point? Yes, my final point is C. Correct. Yeah. So my final point VC minus my initial point is A, VA divided by DR. That's what I have taken here. My EAC is equal to minus of VC minus VA upon DR. This is my potential electric field. So I just took E cos theta. I didn't take E cos theta. I took E is equals to minus dV by dr. E is equals to minus dV by dr. So I'm assuming theta is 0 degree. Okay, theta is 0 degree in this direction only, guys. In this, with respect to this direction only. Okay, if I consider this as my coordinate system, with respect to this coordinate system only, I got my angle between the electric field and this coordinate system is 0. So if I take this as 0, cos theta as 0, then E is equals to minus dV by dr is the relation which I get. Okay, in this direction only, my change in potential is given by VC minus VA. So I apply here minus VC minus VA by dr. I get VA minus VC by dr. So electric field upon along EAC, electric field along EAC will be equals to VA minus VC by dr. This is how we get the electric field. Got it, guys? Did you get this? Did you guys get this? Click on us if you have got this. Click on us if you have got this. Yes, how to find electric field if the potentials. So you know now how to find electric field if the potentials are given. So guys, if you know that, then tell me what is the formula for electric field along AB direction? What is the formula for electric field along AB direction? Reply in chat, reply in chat, guys. Reply in chat. Is it VA minus VB or VB minus VA? What is the answer? Try to reply in chat, guys. So you have understood that previous one now. Now tell me this. YouTubers, please try to answer. Yes, correct, Hari Prasad. Yeah. Yes, correct, Dhanush. Super Tejas. Others, guys, come on. Yes, correct, Prajwal. Awesome. So you guys are super, guys. Really superb. You are responding. Thank you. It's really appreciative for you guys. Like, yeah, it's really great that you guys respond. So, yes, Prakash Gowda, super. Prakash is correct. Super Hari Prasad. Awesome. So yes, my change in potential. So what is change in potential? Say guys, in this system, I'll take my coordinate system in this direction only. I'll take my coordinate system in this direction only. So my angle between the electric potential or electric field and the axis coordinate system is same. So 0 degree. Then e cos theta, e cos 0 is 1. So that is E into 1, that is E. EAB will be equals to change in potential along AB direction. So final point is VB and initial point is VA, VB minus VA upon DR. So this I'll get as what? Yes, V minus VB plus VA by DR. That is nothing but VA minus VB upon DR. So this is the expression for electric field which I get. Correct, Devikaraniam. Superb. Okay, guys, got this. How to find electric field if you know the electric potential? People, you got to know how to find electric field if you know the electric potential. Yes, YouTubers, try to reply. Guys, here, please try to reply. Yes. Okay, cool, guys. Thank you. So, yeah, this was expression which we get. So I'll try to erase this. Yes. So this is the expression which we get for electric field along EB, EAB. Okay, so guys, cool. Then what can you say? Okay, we'll again check on the properties. Okay, cool. So if for theta, we know dV is equals to minus E dot dr and E cos theta is equals to minus dV by dr. From here, guys, now we'll just have a quick summary. Okay, if my theta is equal to 0 degree, if my theta is equal to 0 degree, what happens to the electric field? If my theta is equals to 0 degree, what happens to the electric field? Tell me, guys, using this relation, if theta is equal to 0 degree, yes, my electric field will be maximum. If theta is equal to 0 degree, then my electric field will be maximum. Okay, then what can I say about the direction of electric field? Guys, you know already. What can I say about the direction of electric field? My direction of electric field, the direction. What can I say about direction of electric field? Okay, or can I predict? I'll change my question. Okay, first tell me this answer. Yes, correct, Hariprasad. E is equals to minus dV by dr, right? So if E cos theta, if cos theta, if cos of theta is 0 degree, if cos of 0 is equals to 1, then E is equals to minus dV by dr. This is maximum. If, okay, as my theta increases, what happens, guys? As my theta increases, what happens to cos theta value? Guys, you know this by maths. Yes, correct, Devikarani. Cool. So you know this by maths, right? Awesome, Hariprasad. Yep. Yes, as my theta increases, my cos theta value decreases. So you know this by trigonometry of your 11th standard. Yes, correct, Arun. Correct, Prajwal. As my theta angle between the electric field and the direction of my charge increases, then the cos theta value decreases, then the what happens? So if my cos theta value, if theta value increases, cos theta value decreases now, then what happens to the electric field magnitude, guys? If my cos theta value goes on decreasing, what happens to the electric field? If my theta, if theta increases, cos theta decreases now, then what happens to electric field? Yes, the electric field also decreases with the magnitude of cos theta. Cos theta is how much cos theta would decrease with same amount of magnitude, my electric field also decreases. Okay, correct Tejas, correct Arun. Yes. Now guys, tell me, yeah, in which direction is my electric field? So I think Hari Prasad answered this. Others try to answer this. So my electric field direction would be in the direction of higher potential region to lower potential region, right? Okay. Now tell me, if I know the direction of electric field, can I predict where my potential, what is the magnitude of my potential? Guys, if I know the direction of electric field, can I predict the potential at that point? If I know electric field, can I find V? Okay. If I know E and theta. Okay. If I know E and theta, can I find V? Yes, no, something, reply please. My question is, yes, if I know the electric field E, can I find electric potential V? Okay. So the electric field, yes, correct. Yes, we can find. So what can we say from these? We can say that the electric field is along the direction in which my potential falls. See, in our previous sessions, we understood that electric field is always in the direction of higher potential region to lower potential region. But in which particular direction? Where my potential falls the fastest, not only falls, it should fall the fastest. Okay. Yes, yes, correct Devika Rani, correct Hari Prasad. Thank you for your response guys. So yeah, electric field is along the direction in which my potential falls the fastest. Okay guys, so what do you mean by this? Where we apply this, we'll learn. Okay, now tell me, as my theta increases, cos theta decreases. If my theta value is 90-degree, what happens? If my theta value is 90-degree, what happens? For theta equals to 90-degree, what happens? What happens to cos theta? What happens to cos theta? If my theta is 90-degree, my cos theta value is cos 90. That is 0, right? That is 0, not 0-degree. It's absolute 0. Yes, Hari Prasad. On after 90-degree, cos value will be negative and E will be positive. This means E increases. How will we say it decreases only? See, exactly at 90-degree. Yes, the magnitude wise it will be 0 at 90-degree. Magnitude wise it will be 0. Okay. So Hari Prasad is asking. So after 90-degree, say in the number line, if we see in the plane, so this is first quadrant. In first quadrant we have 0 to 90-degree. After 90-degree we have second quadrant, right? In second quadrant, what is cos value? Cos value, guys, I hope you remember this in your trigonometry. All sine, tan and cot, and cosecant and secant. I hope you guys remember this from your trigonometry. So I remember it as all silver teacups. I don't know. So all sine, cos, I mean something like that. Guys, you remember that? Do you remember that? So if I have a number line, if this is first quadrant, if this is okay, this is argand plane. So this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Okay, all students take care. Okay, even that, nice. Yeah, all students take coffee. Okay, even that, nice, Anusha. So there are several ways to remember, right? So here all functions are positive. Here sine and the cosecant. Tell me. Uh, yes, means sine and cosecant. Is it? Is it sine and cosecant, guys? In second quadrant, is it sine and cosecant? Please reply. Yes, sine and cosecant are only positive. Here, tan and cot are positive. And here, uh, What was all silver T? What was C for? Co- Cos. Okay, cosecant times secant. Is positive. Then here, what is the other function? So only sine is positive. Okay, I don't know. So this your maths teacher would explain you better. So he will be knowing, and you guys might be knowing. So it's been long time. Okay, sine and cosecant. Okay, thank you, everyone. Thank you all. So yes, Hari Prasad, to answer that question, yes. So only these functions will be positive in the respective quadrants. Other functions will not be positive. So other quadrants will be negative, right? In that case, if you see the negative sign here and negative sign here, okay, okay, cool. Thank you, Devika. Yeah. So negative sign, when this turns negative, then the electric field will become positive now. So in that case also it will increase. Okay. So let's come back. So if theta is 90 degree, if my theta is 90 degree, then what happens to the electric field, guys? What happens to electric field? If theta equals to 90 degree, my electric field value will be heli. So if theta equals to 90 degree, my electric field will be 0, right? My electric field at that point will be 0. Then yes, the change. So what is that point? We'll learn that. So what happens in this case? My dv by dr is equal to 0, or dv is equal to 0. Then we can say v is constant in that point. My electric potential will be constant at that point. So what are these surfaces called? Yes, it may decrease, increase or decrease depends on theta. Correct, Hari Prasad. Yeah. So what is this point called as? So where my potential is constant throughout. Okay. When my potential is constant, my change in potential delta V at any 2 points will be V minus V, that will be equals to 0 always. So this is what it means. At E is equals to, or E cos theta, at theta equals to 90 degree, we get the potential is 0. Yes, correct, Dhanush. Those are the equipotential surfaces. We'll study that today. Okay, guys, quick concept test for everyone. Try to answer this question. So this question states that, so there are two statements given to you guys. So first statement is the potential drops in the direction of electric field. Statement 1 says the potential drops in the direction of electric field. Statement 2 says the direction in which the potential drops is the direction of electric field. Okay. Can you find the difference between the two statements? Okay, now you should say which one of these two statements are correct, are true, or if both are true, if both are false, if both one of it's true, one of it's false. All four options are given to you guys. Come on, answer. Think and answer, guys. Think for some time and answer. Okay, guys, please think. I am insisting everyone to think. Okay. See, think of two statements. If you did not understand any statement, let me know. I'll try to answer you guys. I'll try to explain the question properly. So anyone requires any clarification? Yes, correct, Hari Prasad. Yes, anyone requires any clarification? Bhargav, no. Hari Prasad, no. Prajwal, no. Okay. So guys, please think of your answer. Tejas, correct? Okay, only Tejas had given me right answer so far. Others, think. So you'll get such questions everywhere. So this will be somewhere the easiest question, but you should know the concept theory wise. Okay, theory wise, you should know the concept properly. No. Hari Prasad, no. Prajwal, correct? Prajwal, EM, correct. Bhargav, no. Guys, yeah, try to answer this question if you have applied, if you have understood the previous concept. Every point, okay. Sayyad, no. Okay, is that Sayyad? I don't know. Namrata, right? Yes. Why are you in doubt? Namrata, chill. You are correct. Nisarga, no. Amulya, no. Please, guys, focus on the focus. Guys, try to focus on the question. Focus on both statements. Focus on words. Focus. Focus properly. See, observe. No Bhargav, no Syed, no Manju, no Dhanush. Okay, guys. Shall I display the answer? Or shall I go to, okay, I won't display the answer right now. I'll give you a hint, okay? Dhanush, yes. Prajwal, no. Prajwal, yes, no. Okay, listen, guys. So, first tell me two things. Tell me first one thing now. Okay. Say, I have my higher potential. I have a higher potential here. I have a lower potential here. So, in which direction is my electric field? Tell me this. Left to right or right to left? In which direction is my electric field? In which direction is my electric field? This one. I have VL. VL is less potential. VH is higher potential. Yes, Manju are correct. Yes. My electric field will be from left to right, right? Will be from left to right. Prajwal. Yakappa. My electric field is always from correct Hari Prasad. It will always go from higher potential to lower potential. So, which among these two statements shows that? Which statement? Statement one or statement two shows that? Which statement shows that? My electric potential always moves from higher potential to lower potential. Which statement shows that? One or two? Reply, guys. Reply. Which statement? So, okay, my electric field is always in the direction of higher potential to lower potential. If I try to twist this, yes, if I try to twist this statement, my electric potential drops in the direction of electric field. See, as my electric is in the direction of electric field, my electric potential drops, gets on decreases, right? In the direction of electric field, my electric potential drops, correct? So which statement shows that? No, Sayed, not statement 2. Statement 1 shows that my potential, see, it says the potential drops in the direction of electric field. See, in the direction of electric field, my electric potential drops. Okay, now come to this second point. Okay, come to check this second point, guys. What does this second point say? Focus here, focus here. What does this second point say? Electric field is along the direction, the electric field is along the direction in which the potential falls the fastest, right? The electric field is always along the direction in which the potential falls the fastest. Guys, the keyword is the fastest. Okay, you have to remember this. This is my keyword. The electric potential falls the fastest. So please remember this. This term is very, very important, guys. So whenever my electric field reduces, wherever my electric potential reduces, that is not the only the electric field. I mean, that is not the only direction of electric field. Okay. If my potential is decreasing, that direction is not the electric field only. See, the condition is it should fall the fastest. Okay, I'll give you an example. Okay, say I have a surface. Okay, wait. I have, see, to make this understand, I have a surface, equipotential surface. I have in this direction, say my equipotential at this point, my equipotential surface at this point. At this point is 9 volts. Okay, say at this point is 9 volts. Now I'll give you two cases. Okay, I'll give you two cases. After some time my potential is 5 volts. After a distance of 10 meters, not 10 meters is too much, 10 centimeters, I'll take 10 centimeters. Okay, after 10 centimeters my potential is 5 volts. Okay, and this is one condition, first condition. Okay, I have second condition also. In the second condition, Kelly, listen, guys, in the second condition I have some electric field in both directions. Okay, I have a field, so my equipotential surface or my electric potential at point, first point, so at this point will be 9 volts again. But in after 10 meters, after 10 meters, after 10 meters or 10 centimeters, my point potential at this point is point 0.9, 0.9 volts. Okay, in which direction do you think? See, here also it's 9 volts at point A, at point B it's 0.9 volts. At the same distance, point A and point B, it's 9 volts and 5 volts. Okay, now is there any difference between these two things, guys? Is there any difference between this example and this example? Example 1 and example 2, is there any difference between these? Confusing statements, Hari Prasad, chill, don't worry. That's why I asked you to focus on this line. Second line is very important, guys. This entire line is very important. So this is very important, guys. Yeah, correct, Prajwal, you got that point. You got the point. Guys, I'm stressing on this. Note that. Okay, now try to answer this, guys. Say first statement says potential drops in the direction of the electric field. Potential drops in the direction of electric field. Second statement says the direction in which potential drops is the direction of electric field. So if I add the word fastest here, if I add the word fastest here, then even statement 2 is correct. Okay, yes, correct, Bhargav. If I add the word fastest here, then even statement 2 will be correct, but unfortunately the statement 2 does not have the word fastest. So guys, my electric field is along this direction only for this, not for this. Electric field is only along left to right only for example 2, not for example 1. Why? My electric potential should drop the fastest. ತುಂಬಾ ಜಾಸ್ತಿ ವೇಗವಾಗಿ, I mean it should reduce so fast. Okay, from 9 volts to 0.9 volts, it's very drastic change. But 9 volts to 5 volts is not a drastic change, right? Are you getting this? So second point states that the electric field is in the direction where the potential drops the fastest. Okay, it should be an abrupt change. I mean very faster change. Only then my electric potential, I can say the electric field is in that direction. So yes, only statement 1 is true, statement 2 is false. This is the correct statement, guys. How many of you gave this answer? Okay, majority of you have given first option. So guys, hope you guys have understood this. Click on yes if you have understood. Guys, are you listening? Yes, correct, Bhargav. Correct, Bhargav. Potential drop in example 2 is faster than example 1. So I can conclude my electric field is in this particular direction only. Guys, Artha Agidya, please click on yes. Click on yes. Okay, cool. So hope you got to know how the statements are and you got to know how to differentiate the statements, right? Okay, if yes, then I'll move on, guys. Please click on S in your participants list. In your participants list, there is an option called tick mark S. Please click on that only so that I can get confirmed how many of you are have understood. Yes, thank you guys. Awesome, super. Okay, and then I have a problem for you guys. Try to solve this problem. So uniform electric field of 10 newtons per coulomb. Okay, guys, this question is. Uh, I have to change the software again. So it's 10 newtons per coulomb exists in a vertically downward direction. Find the increase in electrostatic potential as one goes up through a height of 50 centimeter. So what is given here, guys? Someone explain me the question if you have understood. What does they say? A uniform electric field of 10 newtons per coulomb exists in a vertically downward direction. So in vertically downward direction, there exists an electric field of 10 newtons per coulomb. Okay, in downward direction. Find the increase in electrostatic potential as, say there is one charge, say one goes up means one charge, there is a charge. This goes up, this is going up through a height of 50 centimeters. Okay. So what? How much electric potential will this charge increase? Say there is a charge at lower potential. So we know my electric field is always from higher potential region to lower potential region. You guys know this, right? Now, if a charge is trying to move from this end to this end against the electric field, it moves some 50 centimeters. How much electric potential will it gain? Find the increase in electric potential. Okay, guys. So it is okay. Try to answer this. Try to answer this, guys. Come on. Hope everyone is trying. Okay, Danush, is this the answer for this question? Yep. So first option is 5, second option is 0.5, third option is 50, and fourth option is none of the above. Okay. Nota. Go to your answers, guys. Come on. Cool, guys. Superb, superb, superb. All of you have given me the right answer so far. Yes. Cool. So yes, some of you have given wrong answers too. Please check that. Which formula are we going to use here, guys? Which formula are we going to use here? Which formula are we going to use here? Which formula? Tell me the formula first. Yes, Hari Prasad. Yes, Devika Rani. Cool. Awesome, guys. So most of you have got this. Yeah. So what is given to us? So there is some electric field in this downward direction. E is equals to 10 newtons per coulomb. Okay, newtons per coulomb in minus j cap direction. Okay, it's moving in minus j cap direction. Find the increase in electrostatic potential as one goes up through a height of 50 centimeters. So height is 50 centimeters. That is 5 in 50 into 10 power minus 2. That is meters. That is 5 into 10 power minus 1 meters. Okay. So it's going in with a height of 50 centimeters. Now I know the distance. What is electric potential, guys? We know dB is equals to minus E dot dr. Hope everyone remember this. dV is equals to minus E dot dr, or integrating this, we got V is equals to minus E dot dr. Right? Minus E dot dr. Guys, remember this. So my change in potential V is equals to, okay, come on, So find the increasing electrostatic potential only. So yes, E is 10 minus into 10 newtons per coulomb into dot product, right? Yeah. So E dot dr. So since it's a dot product, I'll also take a dot product. Dot dr is r. What is r? 50 centimeters. That is 5 into 10 power minus 1 meter. Cos 180 na. Cos 180. What is your angle? Angle is cos 180 degree. So what is cos 180, guys? Cos 180 is minus 1, right? Cos 180 is minus 1. So this minus 1 and this negative will cancel. Then what will be my V? V is 10 into 5 into 10 power minus 1. That is 5 volts. So option A is the correct answer. How many of you got this? Yes. See? Yake. Just kadme. Yes, correct, Hari Prasad. You have got the right answer. Cool. So next we're going to discuss about something called as the equipotential surfaces, guys. So what do you mean by equipotential surfaces, guys? So we got to know that my electric field will be in the direction from where to where? From a region of higher potential region to a region of lower potential region, right? Say if I consider at any point, say with respect to electric field, if I go in the 90-degree direction, so if I go perpendicular to the electric field, so what will be my V, guys? V at this case, what will be my V? Please participate. Everyone try to answer. Yes, correct, Dhanush. Everyone need to participate. Thank you. So my electric potential, when I go in the 90-degree, the change in electric potential, not only electric potential, the change in, I should say, change in electric potential is 0. Then if I consider the potential at any point with respect to ground or with respect to infinity, I have at infinity, what is my potential, guys? At infinity, my potential is 0 volts. With respect to infinity, if I measure its potential, so how many of you know there is something called as voltmeter or multimeter? So I can't go to infinity, so I will connect this to ground. So if I measure its potential at this point, any point with respect to ground, what will I get? The potential at this point. Say if V1 is a potential at this point, I'll get its potential. I'll read its potential, right? Similarly, if I go further, yeah, if I draw a perpendicular to this electric field, I'll find another potential V2. So these two, V1 and V2, say if I check any point, so I have this voltmeter now. If I take its lid and check at this point, what will be the voltage, guys? What will be the voltage at any point in this V1 surface, or yeah, any point when we are going in perpendicular direction? What will be the potential? Same or different? What will be the potential? Same or different? Yes, the potential will be same. Such surfaces where my potential will be same along the 90-degree axis, along the 90-degree. When I go along 90-degree with or perpendicular to that of electric field, then at all points along the straight line or along this plane, I can call this as a plane. So guys, this is a 3D space. I couldn't show you, but in upcoming slides, I will show you how this is in 3D. Okay, I'll show you the 3D model of this also. Okay, now this is in 2D. Now we see everything in 2D, 2 dimensions. So we can't see this as a plane, but this is a plane. Okay, this is a plane and my electric field lines are here. When I draw, so how can I define the equipotential surface as? So yes, my equipotential surfaces have same potential. Correct, Bhargav. So always my equipotential surfaces are always drawn with respect to or perpendicular to electric field. Okay, are always drawn perpendicular to electric field. Then what can I say equipotential surface as? Equipotential surface is nothing but it's formed by the equipotential surface is formed by joining the locus of all points. Yes, joining the potentials of all points or locus of all points. What is locus? Guys, everyone who have taken maths would be knowing. Is there anyone who don't know what is locus? Locus of all points means. So if I have a region, if I have a region, yes, if I have a region in a given region, if I join all the points, so I'll show how it's done in 3D. In a region, if I join all the points, then I'll get a surface. So how a surface is formed, guys? How a surface is formed? How a plane is formed? Guys, you know how a plane is formed? Guys, idea here, really get an idea, sir, please. Okay, देखो. So if you have, if I want to try say a line, how much, in which dimension does a line exist? In which dimension does a line exist? Yes, line has only one dimension. It varies along x or x and minus x time. See, you might have studied this in your 11th standard first chapter about degrees of freedom. Guys, idea Gupta. Say, when can I say body is in one dimension? If it has only 1 degree of freedom. You might have studied this in chemistry also. If a body, if an atom, yeah, no, guys, that's the very basic thing, right? In chemistry, at least you might have studied. Say, if you have an atom, if it's moving in this or this direction, only left to right or right to left, then this has 1 degrees of freedom. Or if the same atom is moving up and down, then again it has only 1 degrees of freedom. If an object is moving up and down and right and left, then it's a plane. It has 2 degrees of freedom. ಕಲ್ತಿದ್ದೀರಾ ಇದು? So body can go both up and down and side left and right. Then it has 2 degrees of freedom. ಅದೆಲ್ಲ ಕಲ್ತಿರ್ಬೇಕು. I mean, you should know that by now. Okay, chill. Don't worry if you don't know. It's not of that. It's not that important. So they might have not discussed. Okay. So guys, what? Okay, I can say my equipotential surfaces are planar, always a plane drawn perpendicular to the electric field lines. Okay, so if I join all the locus of points perpendicular to the electric field, I get the surface which is having same potential throughout. So these surfaces are called as equipotential surfaces. Okay, just simple. So that's all. Equipotential is nothing but in a perpendicular, in a plane, in a region where there is uniform electric field. If I take a plane with perpendicular to the electric field, always perpendicular to the electric field, if I take a plane, yes, and if I connect all the points, end points of that plane, then I get a surface, planar surface. This planar surface, or this this planar surface is called as the equipotential surface. Okay, at equipotential surface, at all positions, at all positions, at all positions, at all points, V is same. Okay, whole potential is same. Okay, and we know that in the direction of electric field, my electric potential decreases, so V1 should obviously be greater than V2. Okay, V1 should obviously greater than V2. Next, guys. So what happens? So yes, if I want to represent this statement in form of equations, I can represent it as dV is equals to dV by dr is equals to minus e cos theta or minus e. Then for theta equals to 90 degree, cos theta is 0. Then e is also 0. Then I get e is equals to constant. Then if I take the locus of all points, then it forms a surface. This surface is called as an equipotential surface. Now what happens when an electric field enters a conductor, guys? This we had studied already. So if this is a uniform electric field, a positive electric field, okay. If this is a uniform electric field due to a positive charge. What happens in this, inside the surface or inside a conductor? What happens inside the conductor? What happens inside the conductor? What happens inside the conductor, guys? Tell me. Yes, inside the conductor, the net potential will be equals to 0. Since this is an external electric field, there will be a creation of internal electric field which opposes the external electric field. So if this is E external, so this external electric field will be opposed by internal electric field, which is caused by the, yes, correct, Bhargav, which is caused by the external electric field. This annihilate, these two destroy or cancel out each other inside the electric conductor. So net electric field inside the conductor will be 0. So what can we conclude from this, guys? If net electric field inside a conductor is 0, what can we conclude? What can we conclude? Inside a conductor, what can we conclude if the net electric field is 0? So we can say the conductor has equipotential surface at all points. Okay. If net is 0, that only means, if net electric field is 0, that only means my change in potential is 0, right? If net electric field is 0, it only means my change in potential is 0. ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? Electric field conductor ಒಳಗೆ 0 ಅನ್ನೋದಾದ್ರೆ ನನ್ನ change in potential 0. If electric field inside a conductor is 0, my change in potential at all points, the change in potential delta V for all points inside the conductor, the change in potential inside the conductor at all points is 0. The change in potential 0. This means potential at this point, say what is the potential at this point? V1. And if I consider potential at this point as V2, then V1 and V2 are equal. V1 is equals to V2. So V2 minus V1 will be always equals to 0. Hope you have got this. Click on S if you have got this, guys. Click on S if you have got this. So this is nothing but the equipotential surface. So to represent equipotential surface, we have to follow this. First, check the change in potential. Then the change in potential with respect to distance is nothing but electric field. Or dV by dy is equals to minus E cos theta. If I go in the perpendicular direction at 90 degrees, my cos value is 0. Then the net electric field will be 0. If my net electric field is 0, then I can say the change in potential is 0. If the change in potential, if the change in potential is 0, I can conclude my potential is constant throughout. Okay, then if I draw the locus of all points, I get the equipotential surfaces. This is my equipotential surface. Okay, guys, now if I'll show you the graphical 3D structures of each equipotential surface. So first thing is I have a electric charge. I mean, I have a conductor. Okay, I have a conductor. I mean, this is a cylindrical rod. I have a cylindrical rod. Now, if this is the electric field which is coming out, if this is the electric field which is emerging out, electric field emerging out of the conductor, or a linear charge distribution. Say if I have same charge distributed all over this surface, say I have a surface and I have same charge distributed all over the surface, what happens, guys? Tell me what happens in this case. My electric field in all these cases will emerge out, right? My electric field will emerge out in all cases. So my electric field will emerge out in all directions. Then if I draw a surface at every point, say if I draw a surface at this point, I get an equipotential surface. So the electric potential at all these points will be same. Electric potential V will be same. Okay. Similarly, as my electric field increases, as my electric strength increases, what happens to equipotential surface? See, if V1 is, if this is the electric potential, then in the direction of electric field, my potential decreases, right? In the direction of electric field, my potential decreases. Here, my electric field is very high. As it goes beyond, there is expansion in the potential, so there is decrease in potential. Though it shows there is increase in area, but the potential wise, it is decreasing. So this is how we get the potential at all surfaces. So these are the equipotential surfaces which we see. Okay, this is one equipotential surface. This is another equipotential surface, V1, V2. Again, so V1, V2, and V3. There are three equipotential surfaces here: V1, V2, and V3. Guys, ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ ಗೊತ್ತಾಯ್ತಾ ಹೆಂಗಿರುತ್ತೆ? Are you guys understanding how it would be? How the equipotential surfaces would be for a planar line charge or linear charge distribution? For linear charge distribution, this is how we get the equipotential surfaces. Okay. Next, guys, for spherical surfaces. So this is for spherical surfaces. If I have a spherical surface, if I have a spherical surface, how my equipotential surface would look like? Say if all the electric field lines, see, remember always. So we'll be learning this about this in next class. That is the continuous charge distribution thing. So these are from continuous charge distribution. So we'll be learning about continuous charge distributions in next class. In that class, we'll be learning how my surface charge is, how my charge is being distributed for a given region for a regular structure. ಹೆಂಗೆ ನನ್ನ ಚಾರ್ಜ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗುತ್ತೆ ಒಂದು ಸರ್ಫೇಸ್ ಅಲ್ಲಿ, how my charge is getting distributed. That is going to be discussed here. Yes, once we get to know this, I will know how my electric field, what is the direction of my electric field. Hope guys by now, I hope this is taught in your schools. We will be teaching that again. Is this taught in your schools, guys? Electric field, equipotential surface of sphere, the electric field for any continuous charge distribution. Yes, cool, super, thanks. Thanks for the confirmation, guys. Cool. So we'll be learning that in our next class. So if I try to draw the equipotential surface for this, if I try to draw the equipotential surface for this, I get the equipotential surface here. Similarly, if I try to draw the equipotential surface for next region, say for upcoming this line, I would get an equipotential surface like this. The potential at all points would be same. Similarly, if I try to draw and if I try to rotate this, I get the equipotential surface for a solid sphere like these. So in all cases, my equipotential surface would be same. So guys, one example, which is one good example for us in our daily life, we see, which is one good example for us to check out the equipotential surface, to imagine your equipotential surface, which is one good example in our day-to-day life. I hope somebody might have thought this. Okay, how many of you cook, guys? Guys, how many of you cook in your home? How many of you cook food? Acha, okay, no replies, huh? Secret. Sir, it's a secret, sir. We don't disclose. Okay, chill, guys. See, so I hope everyone might have seen onion. Onion, Iruli. Yes. So you know onion, right? When we cut an onion, how we see the rings inside an onion. So onion has become very costly, so I couldn't afford to buy one and show you guys. It's very costly today. Okay, chill. I don't know why. So you guys could do a research on that later after your 12th. You can try to reduce the onion price in future. If somebody is interested in agriculture or something like that, you can do that. Okay, guys, come on, tell me. Yes, they are concentric spheres now. Exactly like this. This is my. If I draw, if the, what if there are lines? If I draw lines, if I cut, when I cut onion, if I cut like this, no, whatever the cut I do, this, if I call it as my electric field, if I call these as my electric field, then all these concentric rings on all these concentric circles will behave as equipotential surfaces. Okay, all these concentric circles or concentric rings can be considered as equipotential surfaces. Yes, correct, Dhanush, correct, Amit. So this is one imagination for equipotential surface. Then for a planar surface, as I taught you here, as I told you about this case, guys, if you remember this case, equipotential surface for the planar region. So this is how it looks in 3D. So if I have a plane surface, if I have a plane surface, then if my electric field are emerging out in all directions, in both directions, see, in a planar surface, in 2D, it looks like this. In 3D, if I try to draw in 3D, it should look like this. Okay, more like a book. Okay, now this has two surfaces. One, this is first surface, the other end is second surface. Okay, so if it emits electric field in both the directions, you can see here now, it emits electric field in both the directions. Okay, if I try to draw, if I try to connect, what is locus, guys? What is locus? If I connect this point, see, this is locus, guys. If somebody did not understand what locus is, this is locus. If I try to connect this, okay, again wrong color. Which color to choose? Yeah, I choose blue color. Okay, if I connect this point, this, then this point, and this point. If I connect all these points, what would I get? I'll connect all these points. See, these are the locus of points. So if I connect all these locus of points, I will get a surface, right? I'll get a surface. This surface is nothing but an equipotential surface. These are my equipotential surfaces. Hope guys you got how an equipotential looks in reality. This is how it looks in reality. Okay, so how many of you have passed okay, why do we require this equipotential surfaces? Okay, we'll learn that. Okay, cool. I guys hope everyone is able to hear my voice. There is some internet issue. So guys, please click on yes if you have understood how an equipotential surface looks in 3D for all three cases: linear, spherical, and planar surface. Yes, if you have understood, we'll try to go solve a problem, guys. Come on, we'll try to solve this problem. So consider there exists an equally spaced planar equipotential surface. So consider this equally spaced planar equipotential surface. Can you see this, guys? Equally spaced planar equipotential surface. Now, if the perpendicular separation between two of the equipotential surfaces 20 centimeters, what they have given? Okay, so they had given if the perpendicular separation between the equipotential surface is 20 centimeters. So between two consecutive separations, it's 20 centimeters. Then the value of potential of these equipotential surfaces 20 and 40 volts. So I have only two surfaces. Okay. So what they have given, so there is some electric field. In this electric field, I have drawn a perpendicular. I have drawn a perpendicular region. One first surface and second surface. Now between these two, the separation is 20 centimeters. Now one of it has 40 volts. Which one? Guys, left one or right one? One of it has 40 volts. Which one? Left or right? Which one should I put 40 volts? Which one should I put 40 volts? Right one ah? Left one ah? Left or right? Yes, left one should have 40 volts. Right one will have 20 volts. Then find the magnitude of electric field. What is the magnitude of electric field? They are asking only magnitude, guys. What is the magnitude of electric field? Find it. So meanwhile, guys, I hope you like the class. You could give the reply for class. Yes, Prakash Koda, super. Yes, correct, Devika Rani, cool. Hari Prasad, check your answer. Check your answer, Hari Prasad. Yes, Prakash Koda, Nisarga, Namrata, correct. Mega, check your answer. Mega, check your answer. Prajwal EM, correct. Dhanush, check your answer. Arjun, check your answer. Sorry, Arun. Sorry. Arun, check your answer. Yes, Amit, correct. Correct, Hari Prasad. Correct, Hari Prasad. Mega, check your answer. Come on, guys, try to answer this. This is simplest of all. I think this is simplest one. So I'll slowly increase the difficulty level of problems, guys. Yes, correct, Danush. If you are, this is easy level problem, so I want everyone to solve this. This is direct substitution, guys. Nitya, check your answer. Mega SP, check your answer again. So may have to end the poll for some time now. Guys, the other poll, please try to give it fast. I can get this. Okay, which formula should I use, guys? Come on, let us discuss the problem. Which formula should I use here? Which is the formula you have learned so far for electric field? Relation between electric field and potential, guys. Come on, tell me. dV is equals to minus E dot dr, right? Or if you're integrating on both sides, you'll get V is equals to minus E dot R. So what is given here? Should you consider V or delta V? So we are going to consider delta V, right? Or we'll consider this minus E is equals to dV by dr. Okay, we'll consider this one. Please try to find this, guys. Yes, correct, Prajwal. Superb, Prajwal. Awesome. Yes, everyone try to use this formula and solve now. Everyone try to use this formula and solve. You'll get the answer. Yes, Mega, correct. Now you got the answer. Nitya, correct. Nitya, correct. Yes, Devikarani. Devikarani, you missed the sign. Even Hari Prasad, you missed the sign. It's always, don't forget the sign, guys. It's minus of dB by dr or minus E is equals to dB by dr. Don't miss the sign. Even missing a sign will cost you a mark, and it will cost you marks. Ganesh Rao, correct. So guys, always remember the formulas. Okay. So hope everyone is trying to make a formula book, guys. Do you have any formula book so far? How many of you have done this? Guys, how many of you have done a formula book for yourself? So I want to suggest everyone one thing. So do one thing today. Okay. Buy a 10 rupees notebook, which you get the small one. Okay. Buy a 10 rupees notebook. Then try to write all the formula. So keep a separate book for physics. Okay. This is a task for you guys today. You'll do this. Everyone, all YouTubers, all people, all YouTube people, and all no, yeah, all YouTube people and all Zoom people. You have to do this. Take a notebook, purchase a notebook today, 10 rupees one, small one, 100 pages book. So yeah, start writing very clearly. So make short notes of your own, okay? So far I have taught till electric potential, right? So we have completed theory part of electric potential, and we have also completed most of the problems. There are few problems pending. So there are some 2, 3, 4 problems pending. So we'll do that. Okay, I'll give you all the problems today with your notes. You guys have to try in your home. Once you got the problems, okay, do you have to do this? So from next class onwards, we'll be starting the next topic. Once we are done, okay, we'll anyway discuss those 3, 4 questions. Once these 3, 4 questions are discussed, I'll give more questions as assignment. So I'll be sharing another DPP. Sorry guys, I was not able to share the second DPP because there was some problem with my personal laptop. I mean, not my personal, the company provided laptop. It had all the questions. So yeah, today it got recovered. So I'll be sending all those things today with the notes. Okay. Yeah, so our next class is on Monday, right? Till then you guys have to do this. Okay, first thing you, okay, I'm assigning you work. I'm assigning you two works. First thing, make short notes. Make short notes. Okay, you should do your own short notes, whatever I have covered so far. Second thing, solve DPPs. Solve DPP. So some students had doubts in some 2-3 questions in my first DPP. That is question number 1, question number 7, and question number 8. So these 3 questions belong to continuous charge distribution, or next topic. Okay. After that topic, you can solve those questions also. Okay. So third thing is solve these 3 questions. Solve 4 questions which are pending next. So 1, 2, 3. Okay. One more. Okay. There are 3 questions only. Three questions. So solve these 3 questions. Or Monday we'll do this. Okay. If possible, if there is time. Okay, there is more time, we can complete this. Okay, once we have completed this question, we'll complete next question also. Then we can complete further more questions. Okay, we'll solve more questions, guys. So don't forget to make your short notes. So how to make short notes? If you want steps, I can give you how to make short notes. Okay, so answer this question, guys. So it was minus E is equals to change in potential. What is my change in potential? What is my final potential? So my potential is 20 minus 40, or 40 minus 20. VA minus VB in the direction of electric field. 40 minus 20 by 20. So that is minus E is 20 centimeters, guys. Remember centimeters. So 40 minus 20 is 20 by 20 into 10 power minus 2. So again, this was minus E is equals to 20 cancels, 10 power minus 2 becomes 20 power plus 2, that is 100. E will be minus 100. So since they have asked magnitude only, so magnitude of E is 100. 100 what? Volts per meter. 100 volts per meter. So this is my answer for first question. Okay. So next question, guys. I want everyone to try this. So meanwhile, I'll explain you how to make your own self notes. Okay. So to make self notes, guys, first take a book. Okay. Yeah. Meanwhile, you try to solve this question and listen. Okay. So to make your self notes, take a book. So in your book, you will have 2 pages, right? In your right page, start with electrostatics, very first. Now, what was the first topic we learned in electrostatics? It's the definition. So how will you write? So I don't want anyone to write paragraphs. Everything should be coded. Electrostatics, electro means charge, statics means rest. Only this. No writing of any line. There should not be more than 1 line or 2 line for any given topic. Everything should be coded. If you know, if there are computer science students, you know that flow chart, right? Try to draw the flow chart. Okay, try to remember all concepts as flow charts. Try to draw the flow chart by yourself. And if somebody have completed, please post me in my WhatsApp. So my WhatsApp number is this. Everyone, YouTube students and Zoom students, please do this. Make your short notes. Make your own short notes. At least until what I have completed. Make short notes until this topic, electric potential. This is your task. ಹೇಳಿದಷ್ಟು ಮಾಡಿ ಪಕ್ಕ ಏನೋ ಒಂದು ಆಗ್ತೆ ಇಲ್ಲ ಅಂದ್ರೆ ಕಷ್ಟ. Okay, so make short notes. And if anyone have got this, okay, take this question as homework. If you can solve, yes, Tejas has solved this. Come on, Tejas, super Tejas. I'll give you the answer, guys. The answer is Tejas. Check your answer again. Tejas, please check your answer. So guys, this is homework for you guys. The answer is option D. We'll solve this question in our next class. Okay. If you have any doubts in this today's class or any previous topics, please ask now. Tejas, please check that. Check your answer again. So it's not option C. So I have given you the answer. So take this as homework. So guys, how to solve this? I'll explain you how to solve this. Okay. So what do we have here? We have equipotential surfaces at an angle 30 degree. Yes, correct, Tejas. Superb. You got that. So we have all my electric. Okay, cool. Thanks, Hariprasad. Cool. Thanks for the response. So we have all electric potentials in this particular direction, which is at 30 degrees. Okay. At 10 centimeter, I have 10 volts with angle of 30 degrees. At 20 centimeters, I have 20 volts at 30 degrees. 30 volts at 30 centimeters. 30 centimeters, we have 30 volts at 30 degrees. At 40 centimeters, I have 40 volts at 30 degrees again. Right. But what did we learn? Equipotential surfaces will be always along 90 degree, right? Now, to make your life simpler, see if this is 30 degree, then the distance between them is not only 10, it's this distance. You have to calculate this distance. Okay, you have to calculate this distance. Either you have to calculate this distance or convert these slanting lines into straight lines, standing lines. Convert the slanted lines to straight lines. You have two methods of solving this. Either convert these sleeping lines to straight standing lines, or find this distance. Find the distance between slanted lines. Anything is possible. So you can follow two methods. For both method, you have to do integration and apply trigonometry. Okay, this is the method. This is a step how you do. Either find what is this distance or make these potentials in vertical direction. Take these potentials in vertical direction. Okay, got this? How to solve, guys? Yes, if you have got this and if you're trying, click on S. If you got this, how to solve, and if you're trying, click on S. If there is any doubt in any of the concepts so far, guys, please ask me. Okay, at any time you are free to call me or contact me with this WhatsApp. This is my WhatsApp number. I have 9741741659. Guys, I'll be free always. I mean, I'll be awake. So anyway, I'll sleep very late. You could ask me all doubts at any time you want. So I'll try to reply to your doubts within some short duration only. I'll try to reply. Okay. Okay, guys, then. Okay, see, Namrata again. Yeah, guys, I'm going to repeat this, how to solve this question. See, to solve this question, what they have given equipotential surfaces, but not straight lines. They have given us slanted lines. What is the angle? Angle is 30 degree. You have two methods to solve. And one formula. What is that formula? Minus E is equals to dV by dr. This is the only formula which you are going to use. Anyway, or if you want to simplify this in any different form, you can try that. So V is equals to minus E integral dr. You can also do this. Sorry, E also goes inside, right? Since both are changing. Okay, minus integral E dot dr or ds. So you can use this or this, any of the form. You can use any of this form. So what will you do? See, either take E cos theta, or E sin theta, whatever, to find what? To find the separation distance between these two. What is the separation distance between these two? So guys, at vertical lines, it's 10 degrees. Remember, at vertical lines, it's 10 degrees. When it's slanted or when it's deviated by 30 degrees, it's not 10 degrees. I mean, so when these are 10, I mean, when these are 90 degrees, say if these equipotentials are standing straight, with 90 degree, then their distance is 10 centimeters. Okay, between these two, it's 10 centimeters. Otherwise, it's not 10 centimeters. It is, see, if you have the projection, it's cos of whatever the thing, right? Cos or sine of whatever the projection. Say, if I want to simplify that, if I have a vector A of length 10 centimeters along x-axis, what would be its length, right? If I have another vector here, vector B, if I have vector A and vector B, if vector the length between these two is 10 centimeters. So if I say its initial case, in initial case it's 10 centimeters. At standard condition, is will it be 10 centimeters only? So you have to take the projection. Okay, try to take the projection, find the distance between them, then solve with 30 degrees only, Namrata. Or yes, correct Tejas. Okay. Or do this, make them make the angle 90 degree. So take the projection of these to make them 90 degree, then find the with keeping the same distance which they have mentioned in the question, you can solve. Okay, this is the only one step you have to do. Yes, sorry, Prasad. So that's what I said. See, okay, they have given 10 centimeters. Is see, some equipotential surfaces are shown in figure. What can you say about their magnitude and direction? This is the question. Okay, what can you say about their magnitude and direction? Is the question. So what will you do? You have to find the magnitude or direction of electric field. You have to find what is E. You have to find what here? You have to find E. Right. So, you know, my equipotential surface will always be in a vertical position. Alva, you know, it's always will be in vertical position. Do one thing, convert these slanted lines to straight lines, which are at 90 degrees. So what will be the distance then? If you convert these slanted lines to straight lines, then the distance between them will be 10 centimeters each. Otherwise, do this, when they are slanted, when they are in slanting position, what is the net difference? I mean, what's the net distance? Say, okay guys, I'll give you an example. So if the length of vector L is 10 centimeter along this direction, when it and makes an angle 30 degree, okay, then what will be its projection on x-axis? What will be its projection of along x-axis? Lx will be what? So someone had answered this already. So Hari Prasad, this is for you. If you can answer this, you'll get the answer. If you can answer this, you'll get the answer for how to find the distance, net distance between two consecutive electric potentials. So once you have done that, here's all links. Yes. Once you have done that, you'll get the answer. Okay, guys. So, guys, yeah, that's all for today. Then we'll wind up for today, and we'll meet all of you again in Monday. Okay, guys. Till then, bye bye. Bye, guys. Bye bye. Hope you like the class, and yes, we'll meet again on Monday. Monday, right? We have class tomorrow. No. Okay. Till then, yeah, remember the works which I have given you. One is to make your short notes. Two, make your solve the questions homework. And three, solve the DPP questions. Okay. Okay, guys. Devika Rani, theta will be 90 minus 30. Yes, correct. No, it's not 90 minus 30, Devika Rani. Please check that. Theta will not be or okay, well, what are you asking, Devika Rani? If you're asking for electric field, Devika Rani, are you asking for electric field or for electric potential? Are you asking the theta for electric field or electric potential? Okay, I'll solve for both conditions. If it's for electric field, okay, take care, Hari Prasad. Thank you. So if it's for electric field, then the electric field angle made by electric field will be 90 plus 30. Yes, correct, Devika Rani. That's the correct answer. Devika Rani, you got the answer. Correct. Awesome. Acha, Mega, send me Mega SP. We'll discuss that in tomorrow's class. Otherwise, you send me what you have done. We'll discuss that. Okay. You send me what you have solved. Na? That paper you can send me in your WhatsApp. So we can solve that. Okay. So I have to end the class by 6:30, guys. So yeah, you could have asked these doubts. Yeah, yeah. Anyway, you can ask these doubts in WhatsApp if you have further doubts. Cool.